All right, welcome to Techorama TV. We are here today exploring one of the most transformative topics in our industry at the moment, which is artificial intelligence. Now, we're going to talk about how that's reshaping all sorts of things, from development, creativity, just our roles as developers. And to help unpack that, I'm joined by these three incredible guys here who are going to help us answer some of these questions that we have about AI. First, Alan Smith, who's been bringing AI into the hands of real-world developers for quite a while now. Jeff Prosise, who makes complex AI understandable and practical, just get our hands on it and tangible. And Scott Addie, who helps developers integrate AI responsibly and effectively kind of into their everyday solutions that we're building and tools. So, with that, let's get started. I'm going to start by just kind of centering ourselves and grounding us on how we're using AI. Are we using AI well today in what we're doing? Because it's everywhere right now, but how well is it going? So, the first question I have for you all, feel free to jump in, whoever has some thoughts here, but what's the biggest misconception you see about AI in software development today?
Yeah, I think all of this, the code generation, that developers are going to be redundant and AI is going to be creating apps for us. I still write lots of code. I've been writing code for money for 30 years, writing code for no money for quite a few years before that. And I find, even with such a long experience of programming, probably you find this the same. How do I save this to a JSON file in Python? Or how do I load up this CSV and split this and display this as a graph? The stuff that everybody's done before, it's just so easy to just have the Copilot create code for you. But anything that's kind of just off the script, I'm doing a lot of coding with music now. If I want to do like harmonic embedding of music, then it's like the Copilot is just like having an annoying code programmer with an extra keyboard connected to the computer that will just suggest stuff that's not really anything like what you want to do. And I think programmers will find that, if you're doing anything that's, their niche, their problem-solving ability, the AI is not going to be the best tool for solving that. And you do need, somebody to actually think through the problem and solve that. So the problem-solving abilities I see, that they're not good at solving problems. They're good at remembering facts and remembering that they've seen code somewhere else to do something, but not to come up with an original creative solution to a complex problem.
To follow up on that a little bit, isn't everything that we do just derivative anyway? It's just taking other ideas we've done before and kind of composing it together in new ways to solve new problems? Why wouldn't AI be able to kind of help us in those ways?
I think, just the code generation, it's seen a lot of code, it's seen everything on Stack Overflow. And there used to be this, when you're working with anything, a new language, a new library, you hit an exception, you copy-paste the exception into Google, then you get a link to Stack Overflow, and you get the solution, you copy-paste that code from Stack Overflow into your solution, and it works. And the AI is just basically doing that for you. It's able to, kind of create code based on what you do as a comment. And they're good at being able to predict based on this particular comment, what is the method that comes after, what is the code that comes after this particular comment. They're, sequence generators. They're good at being able to predict what comes next in a sequence. That's really what they do.
So that workflow that Alan just described of we do something, we get a response back, we might have some errors, we go search Stack Overflow or Google, which ultimately takes us to Stack Overflow, we get an answer, we go try some things. Has anybody used the feature in Visual Studio now that's like debug with Copilot? Have you seen this?
Not yet.
Okay.
But I guess I'd like to piggyback off what was discussed here. It's this whole vibe coding wave. The idea that I can not necessarily be a well-versed expert in the tech stack that I'm expected to use, but with a simple prompt that maybe I feed into GitHub Copilot, I can have a full-blown application produced for me in minutes. And the idea that workflow can replace an entire development team, I think, getting back to your earlier question, that's a misconception, in my opinion. There needs to be a talented engineer or two, possibly more, to keep that AI on the guardrails.
You know, just to add a little bit to that, it's everyone's talking about vibe coding, really interesting. I would contend that vibe coding or AI-assisted coding is a force multiplier. If you start off, you're not a developer, well, something times 0 is still 0, right? The better, the more competent, the more experienced you are as a developer, I think the more you are likely to get out of AI coding and not expect it to take a one-paragraph prompt and generate a 100,000-line enterprise application. We all know you get the best results when you do things in an incremental way. Always tell folks, as you probably do too, that you get out of an LLM what you put into it. The prompting is very important. What's really interesting to me is, I think proper command of the English language or whatever the native language is may be a developer's most important skill going forward, because if you can't describe it to that LLM like you're describing it to a 14-year-old, you're not going to get much out of it.
That's good. So what I'm hearing is English is the new programming language, but not exactly, because you still need to understand the code in the programming language. Like you can't just hand it off and expect magic, even though that's the icon we use for AI everywhere. You mentioned force multiplier. Are you seeing these AI coding assistants and coding agents being a force multiplier and really boosting productivity for developers?
I am. At our company, we give every engineer a choice of GitHub Copilot or Cursor. Probably 60% of them have chosen Cursor, the other 40% GitHub Copilot. I'm very blessed to work at a company with a lot of really smart and talented engineers. I can guarantee you that it's a force multiplier for us. And my observation is the more experienced, the more talented the coder, the more quickly they grasp onto it and the more they get out of it. I saw a study recently, some of you might have too, that said that 95% of the companies that are investing in AI are not getting a return on investment for that. And on one hand, it's hard for me to believe, but on the other hand, I would say, and I hope this doesn't sound too arrogant, they're doing it wrong. Because the rewards, the ROI is real, but it doesn't just happen. You have to know a little bit about what you're doing to get that ROI.
So on that note, if we continue down that path, you all I think agree that it's not just this magical thing that's just going to do the developer thing. We often refer to it as a co-pilot, and I think that's a good way to think about it. Doesn't sound like you think it's going to get rid of developers. What are the things that you have to do it well? You've kind of alluded to like, oh, there's some things you have to do it well, to take advantage of it well, because it's not going to just go out and build the enterprise system for you with a paragraph. So what are those things that people need to be doing to take advantage of this momentum, this wave?
One thing I heard last week that I really liked was somebody saying that these AI is teaching us how to write good specifications, because we need to get that right information into the prompt. We need to be very precise, otherwise it could misinterpret what we say, which is typically what developers may do anyway. So actually having the prompt being a detailed specification document is telling managers that you do have to be precise when you say something, otherwise the AI may misinterpret and create something that it shouldn't be doing. So the detailed spec is good in the prompt, and I think that's going to help people to formulate that for if a developer is building something, to see a much detailed spec is going to be much more helpful.
Again, I'll echo this. It's the quality of the prompt. What you put in, and you made this point, the quality of what comes in dictates what comes out. So there is the necessity to build up that skill. What makes a good prompt or a good PRD, a spec?
I think it's also, at least in my experience, an incremental approach is better than trying to do too much at once. The day may come when we can feed in a 100-page specification and we just magically get 100,000 lines of beautiful code out. Maybe or maybe not. We're certainly not there yet. Getting back to the term force multiplier, I don't expect AI to write an application for me. what it does do for me is the 80% of the time I spend on 20% of the code, just little boilerplate stuff. That's not difficult, but I've got to go remember how to do it, that kind of stuff. It's just so easy with a little prompt to have AI spit that out. And now, instead of spending 2 hours doing something that's not hard, but haven't done it in 5 years, the code is just right there. And the nice thing is, too, we've done it enough that we can look and tell whether that's good code or bad code. The chief architect at our company lives in Sweden. He's an amazing guy, one of the smartest people I've ever worked with. It was just a few months ago that he really started investing in AI-assisted coding. He was very, very skeptical. I wish, when he and I sat down for a couple of hours and kind of started showing him the ropes, I wish I'd counted the number of oh my gods that came out of it. I had a message from him on Slack yesterday that said, I asked it to do this and this and this, and it wrote better code than I wrote. On the other hand, you often hear people say, yeah, but it writes trash code. It does. It's not perfect. But, maybe that's because we weren't giving it the instructions that it needed. One thing about an LLM, you can be as vague as you want. It will rarely come back and say, hey, can you give me more details? Sometime it will. More often than not, it'll just make assumptions. That's when we get into trouble.
That's good. Have you been surprised at all by the adoption, the speed, the rate of adoption that AI has just kind of taken over, and then the acceleration and the rate of change in this space? Has that been surprising, difficult? What's your experience like there?
I can speak to this. I actually see it as a spectrum. On one end, you have the large enterprises that are highly regulated. Let's take healthcare or financial services as an example here. They're still looking at AI, and they're absolutely mesmerized by the terminology that's thrown around. They're still at the phase where they're trying to grasp what do these concepts mean and what should we be doing with it in our organization. Once we understand that, how do the various regulations in our industry get in the way? HIPAA, for example, in healthcare. Or maybe you're in financial services and there's a Sarbanes-Oxley audit that determines what you do. But then on the opposite end of the spectrum, you've got the individuals working maybe in startup type environments, and they're being told, unless you figure out how to become more efficient with the various AI tools that exist, you will not be employed a week from now. They're really being pushed to be on that bleeding edge and figure out ways to innovate and make their business more efficient.
You mentioned something there, which is they're trying to figure out what it can do for them, where to use it, things like that. How do you approach that? How does an organization say, hey, I hear all this buzz in the industry about AI. I want to use AI, but where should I start? How do I plug it in?
Go ahead.
So I have a very strong opinion on that. Doesn't mean it's the right opinion, because I'm wrong very often. In my former role at another company as chief AI officer, my job was to work with customers to understand their businesses, understand the challenges they were facing, and then help them come up with creative ways with AI to make their businesses better and more efficient. And one thing I've found kind of interestingly is that there's a huge fear factor out there. Companies are afraid that if they don't get on top of this, their competitors are. I actually had one guy call me. He was head of engineering at a manufacturing firm in the US, and he said, hey, Jeff, he said, until 2 weeks ago, I didn't know what AI stood for. Now my CEO has said, I got to figure this out before our competitors do. Can you help me there? But my strong opinion is this. A lot of companies are investing heavily in AI. Some companies are seeing an ROI on that, some are not. My observation from working with customers is when the innovation comes from the top down, a lot of companies will set up an AI council or an AI advisory committee, oftentimes staffed with people who don't know a lot about AI. And in my experience, that often doesn't go far. What does work, at least from what I've seen, is You take the people that make the company go from day to day, the engineers, the people in marketing, the people in sales, and you train them up. What we did at our company is we put all of our engineers through a boot camp. And guess what? All the good ideas are coming from the engineers, the people who know where the problems are, where the inefficiencies are, not from the CEO level. So I think that's my long way of saying I think a bottom-up approach as opposed to a top-down approach is a much more effective way to infuse AI into your company and benefit from it.
Any other thoughts on that?
I think also understanding about there's many different disciplines with AI and machine learning. I've been working with it for probably about 8 years, and I started out working, through PyTorch and TensorFlow books, doing the standard, the handwritten digits classification, cats and dogs classification. So I've done a lot with the object detection, image classification, working with video analysis, object tracking in videos, and that is still a big aspect of AI, where understanding what model to use is going to be really important. And I've seen so many teams and companies and individuals just want to throw everything at a large language model and saying, I can send this image to an LLM and it can tell me if there's a cat or a dog in the image. And there's much better, more accurate models to use. So, that was kind of niche. I've worked at a .NET company. I was pretty much the only person doing Python, the only person who'd trained a neural network. And there's still all of that aspect of, the GoFi or good old-fashioned AI that we do need to take into account that's there. And I've been on courses where, teaching workshops and people saying, well, how can I use a large language model for anomaly detection? And you probably don't want to use a large language model for anomaly detection. There's anomaly detection models and technologies to do that. I think understanding that AI is more than LLMs is important.
It's good. So what I'm hearing is a lot of the same things we've always done. It's just we have some new tools to do it with. And so I would imagine the same sort of conversations with engineers and the business, trying to understand the business problems, bring technology to that, make sure your engineers are well-versed and educated in this way. We're solving problems in the same ways we've always done. We just have new tools to do it, which is great. It's exciting. When we are going down that path and we're engineering these solutions with AI now, bringing these new tools to the solutions, what are the biggest obstacles or mistakes that you see people make when trying to infuse AI into their solutions?
I'll chime in here, because I see this a lot. One of the biggest mistakes that I see being made is security is still an afterthought, right?
That's not a new thing. So it's just like what we've always done, right?
Correct.
Okay.
That's always been the can that we kick down the road. We acknowledge it's important, but hey, I just vibe coded something, deployed it to Azure, it works. Let's just forget about why that works. It works, and we can move on to the next task. But eventually, that'll come back and bite that individual that produced that application. Maybe they deployed to Azure, and they should have been using a managed identity and assigned an RBAC role, but it turns out they're using an API key. And when their security team finds out about that, there's going to be an unpleasant conversation.
Yeah, that's good. And security is definitely one of those areas today where this is fluid and still developing. There's a lot of challenges and holes here that we're trying to figure out and navigate through as we start delegating things to agents and making sure it's doing things in a trustworthy, responsible sort of way. So that's good. Yeah.
Yeah, one of the mistakes I see companies make, and you probably see it too, is fine-tuning LLMs when they don't really need to fine-tune them. One thing I tell them is technically there's nothing you can do through fine-tuning that you can't accomplish through prompting. But one reason to fine-tune, one justification to fine-tune an LLM is to reduce the volume of those prompts, especially when the volume is getting very, very high. But there are a lot of things to consider with fine-tuning. It's not free. It costs money. Most companies no longer charge you to maintain the models they did in the early days. But now if a new version of the base model comes out, there's no way to magically transfer the information you find in fine-tuned into the LLM to a new version of it. You've got to go back and do it all over again. So there are cases where it's justified, but in my view, it's not justified as often as I see companies actually resorting to it.
I definitely agree with that, with getting the prompting right in the first time. We had a customer I was talking to, and they had a really interesting case, and what they wanted to do was do like reinforcement learning with human feedback. And I've done lots of reinforcement learning with like gaming AIs, and thought, oh, this will be interesting. So they explained the situation about how, we're not getting good answers out. If there's not a good answer, we want to click thumbs up or thumbs down. We want to be able to, have the users say why it's not a good answer and use those results to, retune the model to make things better. So we looked at the solution, then we looked at the actual system prompts that they were using, and okay, well, we can do a lot to improve the questions by just writing a good system prompt and improving that, and just starting with the basics and making sure that that's correct. And I definitely think, those explanations, and it's still kind of a bit of a mythical science, this prompt engineering. There was a time when people were setting that as their job descriptions on LinkedIn, and it got a lot of hype for a few months, but I don't know if anybody fully understands how to do it correctly, all of the various techniques that we can use, because it just seemed to be more of kind of one of these mythical sciences where there's all of these various rules. If you offer the large language model $10 for answering the question, then it's going to improve the quality of the answers and stuff like that might work, but there's not that much science behind it. I think also being able to have a reliable way of being able to test and monitor the actual results. So we worked on a project where we just basically wrote an exam for the chatbot, and we could give it 300 questions, go away, take lunch, and we got a percentage score that the chatbot got in the exam. And if we modified the prompt and this score went up, then we've probably done something that's good. And I think as well that the testing is challenging, because we're used to, we run unit tests, things go red and green, and you can't do that with LLMs because we're really looking at a floating point score for how well it's answering the question.
So I've heard a couple of things. We've had a great conversation, continuing like this thread a little bit. I've heard prompting come into the conversation, like downplaying fine tuning. At the same time, I've seen, you mentioned like the job descriptions. For a long time, you saw these job descriptions for prompt engineers for these huge $300,000 a year salaries to prompt engineer. And then I've seen articles lately saying, well, prompt engineering is dead. Like that's a thing that's not a thing anymore, and those jobs don't exist. But yet you're still emphasizing the prompting. And I've heard English being like, this is the new language. So you still think that is essential in this process, is really prompting well? And then what are the techniques that people should get familiar with, and how should you get good at prompting?
One thing I tell engineers is explain it to the LLM like you would explain it to a teenager. It's really just common sense, but it's not that easy to do, and it's something that sometimes engineers struggle with. It really is a matter of being succinct, accurate, think about where the gaps are, fill in the gaps, and that will get you a long ways. It's absolutely true that prompting is everything, but I'm like you. When this discipline of prompt engineering first started cropping up, I was like, really? That's kind of interesting. So I'm not sure that I would pay $300,000 a year for a prompt engineer, but give me an engineer who's a competent engineer, a competent developer who can explain these things to an LLM the way they explain it to a teenager, and I'll hire that person.
That's good. So succinct, accurate, direct, probably. Those are all good ways to think about it. You alluded to kind of cost when we were talking about LLMs in here as well. What do you do how do you manage that? How does somebody approach this when they're concerned about what is this going to cost me? Because it's kind of this morphing sort of thing of, you're paying for tokens. I don't know how many tokens you're using. So how do you get a handle on that? How do you manage that through the process?
I don't have a great answer to that question, but what I can say in talking to, for example, universities out there, they're looking at AI and they're recognizing that we need to be using this, but the cost is always a factor. How do we regulate that? If we roll this out to our professors, to our students, things quickly become out of control. There needs to be some sort of a governing body that limits what that total spend can be.
Good. So policy somewhere that's going to monitor and control that. So again, same fundamentals in blocking and tackling that we would have done with any sort of consumption pay for use resource, it sounds like, which is great.
And that might be somewhat temporal too, because until we come up with something better than the transformer architecture to do the things that we're doing today, so assuming we stay with language models for a while, small language models are getting better and better. They tend to be open weights. In fact, I think all of them are open weights. It's not that they're free, because you still have to have some hardware to run them on, but you're not having to pay for those on a per token basis. And one trend that I see is, we have SLMs that are distilled from LLMs, but are designed to do specific things like Code Llama. Yeah, it can generate prose, but it's really good at generating code, maybe as good as that kitchen sink model that has 2 orders of magnitude more parameters. So I think the future, we'll see companies using more and more SLMs, which they're hosting themselves. They're not paying on a per token basis, and they probably won't be using one SLM. They'll be using several. One to help with code, one to help marketing, write marketing content and stuff like that. So right now, yeah, we're paying on a per token basis. I don't know that we'll be doing that forever.
Okay. That's interesting. You mentioned, Jeff, that you might use one model for this thing, you might use another model for this thing. As an Azure guy, I approach Azure AI Foundry and I look at the 11,000 models in the model catalog. How do I know what to do, like what to use, what models to pick? Because they might have, it sounds like, strengths and weaknesses.
There again, and I'm glad you brought this up. I see it all the time. There's this analysis paralysis that developers encounter. They see that inventory of models that are available to them, but oftentimes when they see that list, what they don't see is, which capabilities does this particular model excel at, and once I figured that out, what is this going to cost me? Okay, maybe that's too expensive for the budget that I have. Well, what do I do now? That's another big problem I see out in the wild. If you look at just GitHub Copilot and the tiny drop-down of models that you'd see when, for example, you're using agentic mode or maybe ask mode, there could be a dozen models listed there, but really no further context on which one you should be using. Is it Claude Sonnet? Is it a GPT that I should be using? Who knows? And so what some customers will do is just skip around, try the same prompt with different models and do it that way. And it's not super efficient.
So like do a bake-off or just kind of test them out every now and then and see, is this one doing better or not? It's a reasonable approach. I don't know how else we would go after it. But so are you using, the three of you guys, are you using tools like GitHub Copilot regularly as you're building stuff, or ChatGPT, or?
As a product manager who's come out of software engineering, I find that on my team, I'm expected to know various programming languages, some of which I've never touched in my life. Let's use Golang or Rust as perfect examples here.
Great.
If my engineers in those languages are tied up and they're on the critical path trying to meet a deadline, you best believe I'm going to do my best to fire up agent mode and feed it a prompt and tell it, try and generate a function in this language. Thankfully, I've had very good luck in doing that, and I've been able to, not distract the engineers who, again, are trying to meet a deadline.
I don't think I could do what I do anymore, because I still write code on an almost daily basis without tools like Cursor and GitHub Copilot. Years ago, I used to pride myself on doing conference presentations where I wouldn't use an ID. I'd just type it in a notepad in C#, and it would...
CSC.exe?
Exactly,
Yeah, okay.
exactly. Then I discovered IntelliSense and realized how dumb I had been. Got to the point I couldn't live without IntelliSense. I feel the same way today. I'm so used to using these tools now. It's not that they write all the code for me. They go in, they do surgical strikes and do the stuff that's just going to take me a long time or something like that. I couldn't live without them. Something else, more and more we're all gravitating towards open source. Open source is great. You look at all the open source agentic frameworks out there, there's some great ones. They change every day. So, and the documentation rarely keeps up. What I have found AI tools really good at doing is point them at a repo, point them at a source code file and say, hey, I want to build some code that, let's say, creates an agent, gives it memory that's stored in SQL IDB, and AI, in much less time than I can go into that repo, figure out what that code looks like. So it gives me a jump start, and I'm just instantly more productive. I literally I can't imagine working without them anymore. It's that big.
It's good. So Alan, when building these solutions, we've said, maybe fine-tuning isn't for everything. Prompting is where it's at. When we're doing that, one of the questions I commonly hear is, how do I get my own data into the model? And so kind of feeding off of what Jeff just said, there's these open source maybe models out there. Can I train my own model and feed my data into it and use that as part of the training set? Is there a better way? Like what approach should I take to try to get my data into the LLM, if you will, and then get some responses back with my data?
Yeah, so this comes to like all the agents and tooling, and what we can do is we can provide the language model with tools to be able to retrieve information. So we've got this whole pattern called RAG, Retrieval Augmented Generation, and everybody's talking about, we can chat with our data. And one thing I find that's really assumed when we talk about chat with your data is that your data is going to be a PDF document. And really chatting with your documents is one thing, but I see retrieval augmented generation as being able to just access any external system. So many companies have still got data in a SQL Server database, a relational database. So you can take a user's question, and the language models are great at creating code. So they can write a SQL query to retrieve the information for that particular question. You can query the database, the language model gets the results, and it can then inform the user. And if the LLM has access to the structure of the database, it can figure out the tables, it can figure out which tables to run a particular query and give these responses. So that's quite easy to do. However, you do need to take care about the security, because I did a demo with Nobel laureates that was actually a request we had from the Nobel Institute to answer questions more accurately by using data in a database. You can ask it to change the city where Albert Einstein was born, and it does an update statement. I asked it to add myself as the Nobel laureate for AI, and it inserted me in the database. So this is coming back to the security. If customers if you're not thinking about security when you build these systems, you could build a customer chatbot. And the customer says, how much is this mobile phone? And it says, it's $1,000. And the customer says, I wish it was half that price. If it was $500, I'd buy it. And then the LLM may update the database and change the price. Now we've changed the price to $500. Do you want to buy the phone? That's kind of a bizarre example, but that could very easily happen. And I think one thing that kind of getting into the security is that many vendors are providing tooling where you can just create a chatbot without knowing anything about AI, anything about security, anything about code. You can go into these tools and you can just write a description of your chatbot, and your chatbot appears and it can talk to your internal line of business systems. I see a danger with that. I see lots of advantages in that it's a way of being able to create something very, very quickly. But if you're not understanding the security implications of that, that is going to create some really bad vulnerabilities, I think.
So when you mentioned retrieval augmented generation and RAG,
yeah,
as a technique to get your data in here, you mentioned documents like PDFs or what have you, and that's a common thing. How do I do that? So how do I make the RAG thing work? Like, what's involved in that?
It's really about getting the correct information into the prompt. So we've talked about how the prompting is important, so having a very well-structured prompt. And then extracting the correct information, the relevant information that's going to be relevant to the question that the user is asking. And one of the things that can help with that is doing embedding and a vector-based search. I did a demo in one of my sessions a couple of hours ago where I'm putting some text into Azure AI Search, and then you type in a sentence, and it does a keyword search and a vector search and displays the results on the screen. With a vector search, if you ask the question in French, it finds the correct information because the embeddings or the sentiment of that text is similar when you're crossing language boundaries. So embedding can help as well. And then there's also the challenge of document chunking. So I've been on projects where they give you a 450-page PDF. We want to ask questions about this PDF document. Well, you can't. Well, I suppose you could with larger models. You can actually throw in the entire document, but that's going to be slow and expensive and not the best way. So you need to break down a PDF document and do it not by page or not by 1,000 tokens in each chunk, but each section of the PDF document is its own chunk that can be retrieved and put into the prompt. So when they say, how do I, do my time reporting, or how do I get a new mobile phone, it finds that section from the document. And if you've ever tried to parse a PDF document programmatically and find the headings and the sections, it's not fun. So, I mean, there is in Azure, there's something called the Document Intelligence Service, and that can figure out all of the headings in various documents. And that's a great help of being able to split a document. Another thing that I have a success with is the custom question answer service that can parse a big document and generate these question answer pairs. It's a bit legacy in that it's considered to be legacy because it was used with a bot service, which nobody talks about anymore because we've got chatbots, which are so much better. I hate the bot service. I used it once and never again. But that method of being able to very quickly parse an FAQ website or a big document into the individual chunks very, very quickly is useful. And I've had one case where we've used that is a customer contacted me and they wanted to know how long it would take to build a proof of concept to answer questions from an FAQ on their website. In 90 minutes, we built that proof of concept and published it as a website using the AI Foundry. It's not a ready product, but it's the proof of concept, and that took 90 minutes, and we just used custom question answer to do the actual parsing and generating the question answer pairs from that website.
It's pretty cool. Every time you guys talk, I feel more and more encouraged because it sounds like this is just the stuff we've always done with just different tools, right? We got to, garbage in, garbage out. That's always been the way it is. So we're just doing it with new tools, and we have to make sure we're not feeding garbage in so we don't get garbage out. So this is great, encouraging. So Scott, we have all these great developer tools. Jeff's talked about Cursor and GitHub Copilot, and we use Visual Studio and all those sorts of tools every day. What's the big gaps still of improving this developer experience or getting to this sort of end state that we're marching towards in the developer experience?
So a couple of things come to mind. I think if you look at what's happening in the IDE space, you see VS Code very much leading the way. And then you've got a large percentage of .NET developers hanging out over here on Visual Studio, the larger, older IDE. And that's lagging. It will eventually catch up, but for now, I see a lot of customers moving between the two, doing their actual hardcore development in VS and hopping over to VS Code to take advantage of the latest and greatest AI innovations there. Another thing that came to mind is MCP servers. You were talking earlier about chatting with your own data. So this ability to stand up an endpoint, I'll call it, that is providing additional context to a model. It's based off of Anthropic's specification. That MCP server, let's say you've deployed it remotely, can expose various tools that provide capabilities. And so as a customer, I can be, let's say, inside of VS Code or maybe even in my own agentic application that I've created, calling off to these tools that the remote MCP server is calling. Maybe I integrate with Stripe's MCP server and I say, create me a payment link for this particular product in this currency. And it's just super easy.
That sounds like a great thing just sitting right inside of my IDE. If I could tie that in with all of the tools that I use, all my DevOps things, and then just interact with it in like natural language in my IDE, that'd be great. And it sounds like you guys are making progress in that way in all these IDEs with Visual Studio and VS Code and what have you, right?
And I guess I'll add one more thing. I guess the industry as a whole is in this place where they're trying to figure out what does the future of the IDE look like with all these agentic experiences popping up on a weekly basis.
Yeah.
How does that IDE evolve? And we don't have the answers yet.
So I find myself doing exactly what you described. I've done it for years. I've switched back from Visual Studio to VS Code. But for years, I've done it just for the Git tooling, because the Git tooling I feel like is better in VS Code. But now I find myself doing it as well with the AI tooling. So I'm excited for Visual Studio to give me all the cool things that I love in VS Code there too, which sounds like it's coming, so that's good. So when we were talking about kind of building our AI systems, we've talked about fine-tuning. We kind of downplayed that for a second. We focused on prompt engineering. We talked about retrieval augmented generation. When should I use fine-tuning? We talked about, like, we shouldn't overuse it, but what are the scenarios where it makes sense? When should I use fine-tuning?
So I'll give you one example. Had a customer come to us a couple of years ago, and they wanted us to build an LLM-based app that would write emails for them, which very, very easy to do. But there was a gotcha. It has to write emails in the voice and style of our CEO. So that adds an additional constraint. So that was actually an example of a case where I felt fine-tuning was justified, because we can take 10 or 20 or 30 or 40, 50,000 emails from that CEO, fine-tune with that, and yes, that LLM will be perfectly capable of generating a new email in that style of voice. Now, it is absolutely true, again, there's nothing you can accomplish with fine-tuning you can't accomplish with prompting, but do you want to submit, let's say, 25,000 emails in every prompt just to say generate a new email that says this in that voice? No. Fine-tuning is entirely justified in that case. One other case I've seen where, in my mind at least, it was justified is, Alan mentioned LLMs are very, very good at converting natural language queries into SQL queries, and we can use that mechanism to give an LLM access to a database. One thing we found empirically is that we're much more liable to be successful if we communicate the database schema in each prompt, typically using the DDL, the create table statements and all that. Sometimes databases are quite large with hundreds of tables, which means you're passing all that information in redundantly in each prompt. It's actually not too difficult and usually doesn't take all that many training samples to fine-tune an LLM to understand your database structure. So now with a simple prompt, you can generate syntactically correct queries against that database 99.99% of the time. So 2 examples where I felt it's not only justified, but absolutely the right way to do it.
Style and tone, and then maybe some
database schema?
Yeah, okay,
Yeah.
That's good.
Yeah, I mean, you can do all of this again. One other criteria. If you can do this by adding, let's say, 200 lines to your prompt, don't worry about fine-tuning. If it's going to take adding 20,000 lines to that prompt, think about fine-tuning.
And when we're talking about fine-tuning, what's really happening inside that process? Like, what does fine-tuning really do?
So fine-tuning has been around long before LLMs. When we train a neural network, what we're really doing is arriving at values for the weights and biases that define that thing. Fine-tuning means training with an additional set of training data, typically much smaller than the first one, at a reduced learning rate so that you're making smaller, more incremental adjustments to the weights and biases in each backpropagation pass. The goal of fine-tuning is to instill new knowledge in that model without taking away from the knowledge that it gained in its original training regimen.
So you're really just moving kind of things around in that model, like the weights of things. You're pulling some things down and boosting some things up.
Just making little adjustments to little numbers that make that thing smarter. It's actually quite remarkable when you think about it.
It's pretty cool.
It's actually also focusing on a specific section of the model as well. We do that a lot with vision because the vision AIs, they'll start out with like line detection, shape detection, and it's right at the end when they're doing the more complex features. So you freeze most of the model and then just fine-tune the end part of that model. That's also possible to do it in LLMs because these things are really big. They fit on more than one GPU. And if you're just using a smaller section of the model, it's going to be less expensive to host. And with fine-tuning, it's really the monthly hosting cost. It can be like 1,200 euros a month to host a fine-tuned model because GPU memory ain't cheap and it has to sit on a GPU somewhere in memory. But you can also do it for batch processing, so you can just spin this thing up and use it for a few hours and shut it down again. And that could be more cost-effective if that works for your scenario.
Okay. Scott, when you were talking about people using Visual Studio, this older, bigger IDE, people that have been doing .NET development for a while, I thought about Alan because he is the only guy that I know that uses. He's like the OG. He's been doing this for a while, been doing Python development for a while, and he's like the only guy I know that uses Visual Studio for Python development too. At least personally, I know there's others out there. So I say that to say, I know Alan's been in this machine learning and AI space for a long time. Jeff's been in this space for a long time. How is the industry and the conversations, how are they changing with all of this generative AI and large language model conversations from like what they used to be? And is there still a place for those other kind of traditional applied AI models, those machine learning models? Is there a spot for people to still build those?
Yeah. One thing I thought of as you were talking there was, you mentioned Visual Studio. I always wondered who's checking that Python workload in Visual Studio.
It's Alan. Yeah.
So they do exist. How the conversation has changed over the last year or so, let me address that point there. If we go back to the Build conference, the last one that took place, we heard a lot of customers say, hey, I'm a .NET customer. Seems like I need to learn Python now with this explosion of AI. Turns out that's not the case anymore.
Well, I'm delivering a session tomorrow morning on Python for the .NET developers, so don't tell them that yet. Wait. Yeah.
So I'm not going to steal your thunder here, but you now see us collaborating with external companies. OpenAI is a fine example here where we took over ownership of a community-owned library for .NET developers, revved it from V1 to V2, added all sorts of goodness in it that includes our best practices. Now all of a sudden those same .NET developers that were complaining can come along for the ride and do many of the same things that JavaScript and Python developers have been able to do for a very long time. So that's how I see the conversation changing. We're meeting those customers where they're at instead of expecting them to pivot in their tech stack.
That's good. Things like semantic kernel, which now is like Microsoft Agent Framework, is a great example of that. You know, before that it was LangChain, and it's still that's a great tool, LangChain, LangGraph. But you're meeting developers where they are with the Microsoft Agent Framework. They can do it. They can approach it in their .NET stack as well. So that's fantastic. Yeah, I'm actually going to be on that same sort of topic. So I'm delivering the session tomorrow on Python for .NET developers. This afternoon, I'm delivering a session on polyglot notebooks. So another great example of bringing capabilities like Jupyter notebooks, what we think of as these notebooks, to .NET developers. And so we can do those same kinds of things, which is fantastic. So I do love that. I love that.
Do you remember Azure notebooks? They've been gone for 2 or 3 years. They were awesome.
Yes.
You could even select a C# kernel for those.
Yes.
Such a shame they went away.
Yeah, and so now it's in VS Code, right, with the polyglot notebooks. But yeah, it is. Azure notebooks were really cool for a little while. So yeah. So in terms of like the ML conversation, though, is there still a need for building your own ML models for things?
Absolutely. In some cases, fraud detection is a good example. Worked with a group of engineers in Costa Rica who built the fraud detection model that checks every transaction at Starbucks at the point of sale for fraud. Could an LLM do that? You might twist it around and do it, but no. Because it was trained on a lot of data that was very specific to Starbucks. There are many, many things that we, in years past, would have had to build a model for that we can now accomplish with an LLM. But one thing I think we miss sometimes is AI is about much more than LLMs. Vision models, traditional machine learning models for fraud detection, things like that. Still a place for it. One thing I worry about sometimes is, you've heard the expression, when all you have is a hammer, everything looks like a nail. Sometimes the LLM is that hammer, and they're not always the best solution. In fact, they're oftentimes a poor solution. You know, you mentioned custom object detection. We used to build custom object detection models. Google's Gemini models does do object detection really well, but they can't do them in real time. A self-driving car doesn't have an option of using an LLM to do, a multimodal LLM to do object detection. It has to have that custom one that can work at 30 frames per second.
That's a great example. Yeah.
I mean, the smaller models are so efficient. You can just run them on a really tiny device. So if you do need to run anything on the edge, not connected to the cloud, the device can do object detection. Built in. There's so much machinery. We see you go to the airport. There's all the baggage scanners, security things. You can't feed everything up to the clouds to process that in an LLM. And one analogy I have is it's the energy costs as well. It's responsible to think about that as well. Just because you can, you've got a big SUV and you can drive your kids 200 meters to school in an SUV, you can also, walk with them on a bike, take them on a bike to school, save a lot of energy. And that's very often it's the most convenient way to do things is to use a much smaller custom domain-specific model for that specific task.
So what I'm hearing is, you want to pick the right tool from your toolbox for the job. Again, the same things we've always had to deal with. How do you know what the right tool is from the toolbox, though? We've been talking in this new LLM like Gen AI space about evaluations. What does that look like? How do we know how well the model's performing, what the right model is, what the right tool is? How do we approach that and solve that?
Going back to something I said earlier, I think there's a lot of kind of benchmarking that needs to take place. Pick a couple of good candidates and just compare the two. Manual testing. That would be my approach.
There are evaluation frameworks for sure, but for development teams that have never worked with LLMs before, the thing that tends to be the most shocking to them is how difficult it is to write tests. Little things that we've taken for granted over years, unit tests, integration tests. I mean, think about it. As software engineers, we're used to, you give it an input, you get a very precise output. Now we give it an input, we run it 100 times, we could get 100 different outputs. It makes testing really bad, and it also makes evaluation really difficult because, you can't just run a simple set of tests and say, well, this LLM does a better job of generating SQL queries against my schema than anyone else. It's not that simple.
It's good. You are kind of alluding to something that I think is important here, which is it's not deterministic. And so going back to your, when you have a hammer, everything looks like a nail, you might try to throw an LLM or generative AI at every problem. Might not be the right thing to do, but it's not deterministic. So what are the cases where you shouldn't think about using AI? Instead, you should think about just using some other deterministic method.
I think you need to take a look at are there efficiencies to be gained by using some form of AI tool? If not, you may be wasting your time. Take a look at that. I
would say if there's an algorithmic deterministic way to get to do what you want to do, you should absolutely go with it. Don't use AI if there is an algorithmic way to do it. The beauty of AI to me is that, especially LLMs, it makes it possible to do things in software that weren't possible 3 years ago. For example, take the user input. The user asks a question where, like, what 10 countries did I achieve my top sales figures in last year? And you want to say, okay, I'm either going to provide a textual answer to that question or I'm going to produce a pretty chart and graph. You would never algorithmically be able to look at what the user asked and decide accurately whether to produce a nice pie chart or a piece of text. But with an LLM, that's like AI 101. So use it when you want to do things that are not possible algorithmically. And I think that takes care of 99% of the cases.
It's good. Yeah, I have that same sort of approach as well in the way I think about it. If I'm going to do something that's deterministic, oftentimes we talk about agents being, LLMs being required to build agents. And it's like, well, no, if I'm just using my agent to book a hotel room or something like that, I really don't want the non-deterministic nature in that. I might want the agent or the LLM to deal with the control flow logic, but I want it to book the hotel room every time in the same way, right? So that deterministic process, like, write the code just like you always did in that deterministic way. And I think that's a good way to think about it. So this has been helpful thinking about just all this kind of blocking and tackling fundamentals. That's really the same, like DevOps processes, testing and evaluations, all those kinds of things. One concern I have is that AI coding tools and coding assistants and agents are taking entry-level software engineering jobs. And the reason I have this concern, you all have said, well, it's not replacing the software engineer. You still have to understand software engineering. But if we're not bringing in new entry-level people, how are we developing those people into the future senior-level folks? And so I would just like to hear your thoughts on this and your advice for companies and organizations and how to think about their software engineering teams and organizations and developing talent in their teams going forward.
I actually see things kind of going back in the other direction eventually. I think many companies have sort of over-indexed on, AI can, save us so much cost in terms of, junior level developer salaries. We don't need those 10 developers we previously would have needed. But I think the harsh reality will eventually hit some of those companies, as unfortunate as it is, and they'll recognize that, hey, that summer internship program we used to run, those folks are needed. Eventually we'll have a wave of very talented engineers that will want to retire, and who will replace them? Again, my earlier point, at some point you need a talented senior level engineer who can keep AI on the guardrails. And if that next generation isn't being built up, you're going to have a big problem on your hands.
That makes sense to me, and I fully agree. And we need to be intentional about bringing in the next generation of engineers and training them up. So what are, kind of in closing here, what is the advice you would give to software engineers? What are the skills and the things that they need to be developing to be that 10x engineer, that kind of superhero engineer over the next year, 5, 10 years in their career?
Yeah, I still think, going to school and just studying comp sci fundamentals is something very good, because at the end of the day, just knowing basic data structure knowledge, that will go a very long way in helping craft an effective prompt that you would use.
I would answer the question the same way I answered to my daughter, who's a software engineer back in the U.S. Embrace AI. It's a wave. It's a big wave. We would rather be on top of the wave riding it than under the wave about to get crushed by it. And in the future, I think it's highly likely that developers who are comfortable with AI, who embrace it, who know how to use it as a tool, are going to be much, much, much more marketable. So embrace it, Love it if you can. Me, I love it. I'm having more fun than I've had in 40 years. And learn to use it as a tool because that's where we're going.
Good. Anything to add to that, Alan?
Yeah, I think AI is such a great learning tool because I've been, recommending that .NET devs learn a bit about Python because it's useful to have with machine learning. And I always tell them, I learned Python without a Copilot. You learn Python with a Copilot. It's going to be so much easier for you to learn. And it's great as a teaching tool. Like even as 30 or 40 years writing code, I'm still learning stuff, seeing what the actual Copilot will suggest. Oh, I didn't think of doing that. And yeah, it's helping me to improve.
It's good. Yeah, I'll add some thoughts to that as well. I have a good friend who is a teacher, now as a principal, and she is very much into classical sorts of things and literature, and I've always given her a hard time and said, no, like engineering is where it's at, science and math, that's where it's not all of this language stuff. And I feel like now I'm kind of eating those words because, yeah, that's important, but we need engineers that can write, can communicate their thoughts, can communicate, with others like you're talking to a child, as Jeff was saying. And so all of those other disciplines are really, really important for, I think, software engineers going forward because English is, or language is the way we're going to communicate potentially with these models in some way. So I think that's all important. Well, Alan, Jeff, Scott, thank you all so much for joining us and being on Techorama TV and talking about AI today. This was the Techorama TV AI panel. Thanks so much.
Thank you.
Good job, Eric.